Hello and welcome to our webinar, Behind the Algorithm, Serving the Right Content to the Right People with Andy Catlin, Director of the Data Analytics and Visualization Master's Program at the YU University Katz School. I'm Kelly Milnes, the Enrollment Marketing Strategist at Katz. Before I introduce Andy, I want to take a moment to mention how you can get the most out of this webinar. You can use the chat feature to send questions throughout this event. We'd love to know how you can elaborate on the relevant information that you'll get from our talk today, so please stay in contact with us at katzgrad@yu.edu. We also hope that you'll join us for future webinars relevant to this critically important topic. If you're having any technical difficulties, please let us know via chat and we'll have someone contact you. Also, feel free to send questions throughout the webinar in the chat box. Our speaker today is Andy Catlin, Academic Director for the new Data Analytics and Visualization Program at the Katz School at YU University. Andy is a data analytics and data science expert and an entrepreneur who has co-founded several startups and led teams in building data analytics applications for major organizations. Now let's learn from Andy.
Hello, everybody. Thank you for coming today. Kelly, thanks. I'm Program Director for the Masters of Science in Data Analytics and Visualization program here at YU University. I'm actually domiciled in Florida, and it's a new program. We think it's very exciting, and it will be starting on campus in our Midtown Manhattan campus and online with our program starting in fall 2018. Anyone who is interested in learning more about it, please send me an email and we'll set up a time to talk one-on-one. And I want to jump into the content today. So data-driven marketing is, by this I mean things like recommendation systems and A/B test, ranking systems are one of the most important commercializations of advanced analytics. And so I want to talk today about some use cases, look at under the hood at how one would implement things like recommendation systems, and talk about implications which can be pretty profound, both for good and sometimes for very negative effects. So starting with use cases, I'd like to bring up a page that many of you may have seen something like this. When I'm browsing on Amazon.com, it comes up with a list of items that suggesting that if you're interested in this, you may want to also purchase these items. In an interview a couple years ago, Jeff Bezos, the CEO of Amazon, said that he felt that the recommender system and this ability to suggest things added about 15% to their revenue. And if you know the history of Amazon and how they struggled to become profitable and how they had this love-hate relationship with Wall Street, it's very possible that without the implementation of recommender systems around 2000, that they may not have survived the dot-com bust, and which would mean that the whole retail landscape in the US and the world would be very different today because Amazon has very much reshaped things. A second example is Spotify, a music service. This is my current Discover Weekly page, which is their recommender that suggests songs. And a lot of people feel that the advanced analytics, the data science team at Spotify are the big reason that Spotify actually has the biggest share of the market in streaming music, about roughly twice of Apple, which is pretty amazing for a small Swedish company. So again, an example of recommender systems creating huge value for an organization. To understand how recommender systems work, I think it's good to look at an organization and say, what are the users? What are the items that are being recommended? And what are the preferences or ratings? How do you go about determining how users feel or might feel about specific items? So for Amazon, they have about 300 million users, their last report, about 480 million items, and preferences work out to something like 144 quintillion, which is a pretty big number of possible preferences. Facebook, the users, of course, are the people who log into Facebook, but the items could be other users, that people that Facebook feels you may want to connect to, or advertisements that get sent out, news items. And today we're going to really drill down on news recommenders. LinkedIn, again, connects you with people. SlideShare. Professional sports teams, when they're doing their draft, and I've helped a couple NFL teams with this, are very concerned about ranking algorithms, which is the same principles as recommender systems. You want to know who the top prospects are and how they are relative to each other, particularly with the constraints and desires of your team. We're going to look at this Wall Street Journal site, Blue Feed, Red Feed, which is an example of a news recommender. You can click on, if you search on the web for WSJ, Blue Feed, Red Feed, comes up. And I can pick any of these 8 topics. So I could pick President Trump, and it comes up with a very liberal feed of President Trump's news, and on the other side, a very conservative feed of President Trump's news. With Google's news, we can look at top stories, which is across all users of their news. I can look local, and it can sense it, or I can offer that information, and I can also look at my own personalized news. We'll come back and talk some more about how the Wall Street Journal has attempted to reverse engineer Facebook's recommendation algorithm in a fairly extreme way in this Blue Feed, Red Feed site, and what some of the implications of this kind of news recommender are. I'd like to just mention off to the side, there's a lot of discussion today about fake news. A recent survey indicated that nearly 2/3 of Americans believe that a lot of mainstream news is fake, which I find very discouraging, because I believe that First Amendment and media are very important it's an important institution of our democracy. I personally, when I think of mainstream media, I think of CNN and NBC and also Fox News. When the second Gulf War surge was happening, 2005, 2006, 2 major newspapers, one conservative, decided that they were only going to report stories that were positive, territory gained, for example. Another newspaper, more liberal-leaning, made at about the same time an editorial decision really to emphasize only the stories that were more negative about the second Gulf surge, such as lives being lost. So in both cases, there was a subjective selection of objective facts to present. And I wouldn't say any of this was fake news, but it's also important to understand that there are decisions that are made by editorial boards and by other people that you have to be aware of, because you aren't getting a full picture necessarily. And I certainly believe there's a lot of fake news out there, particularly on the more fringe sites. I realize not everyone shares my opinion about this. I want to also point out about micro-targeting, data-driven targeting. With the advent of big data and the ability to have lots of data about people, with demographic data compiled from smartphone applications, from people opting in to provide information about themselves on their Facebook and other profiles, there's a huge amount of demographic information that allows micro-targeting. So during the recent U.S. political elections, the ads were targeted very precisely and very carefully to certain swing voters in certain swing states, and there was less advertising on television where politicians are forced to broadcast all of their views, and more micro-targeting to selected groups where politicians are able to give different messages. Again, I would argue not so great for democracy. A positive example of micro-targeting, the late Steve Jobs, when he was diagnosed with pancreatic cancer, he had a full genetic makeup done of himself at a cost of, I think it was something like $600,000, which he could afford and most people could not afford. And this allowed his team of doctors, in his own words, to extend his life by 2 or 3 years. So this is an example of what I would consider very positive micro-targeting. And the cost of full body genetic scans is falling like Moore's law. So it's becoming more and more affordable for large numbers of people. So micro-targeting can be used for good and not so good purposes. Next, I'd like to talk about how data-driven targeting works, in particular looking at recommender systems and A/B testing. With recommender systems, if you've ever purchased a book or another item on Amazon, they invite you to rate the item. And with Netflix, they used to have I think it was a 5-star system. They've recently gone to a thumbs up or system. So it could be 1 or 0 or 1 to 5 stars. Different types of systems require different kinds of analysis. Also, ratings can be either implicit or explicit. If you give a rating, that's an example of explicit. Implicit could be that you click through, that you buy an item, that you browse an item, that you recommend something to a friend, that you share a link. And how a recommender system designs to handle this requires a lot of thought in terms of the person doing the advanced analytics. So the next thing that's done is that you take the users, the items, and the preferences or the ratings, and you build a matrix, a user item matrix from it. And this is an example of a user item matrix for movies. One could go in and curate the movies and say, okay, Captain America is 100% action, and Pitch Perfect is 100% singing, and maybe Jungle Book is 50% this and 50% that. Then you can take that information and put it into a content-based system or a collaborative filtering system. And there are different ways of doing the math for this. Here I have it mocked up in Excel, which I think is a tremendously useful tool for doing your modeling. And then you would build out your system in Python or R or another language, and perhaps implement it in Python or perhaps implement it in a language like Java or Scala. So it's usually done with a team. But at the end of the day, you would want to be able to do things like say, what movie that Xingja has not yet seen is she most likely to enjoy? And with a handful of items and a handful of users, you might say, well, she probably would like Pitch Perfect. Of course, she hasn't rated any action movies, so it's tough to tell. It's also probably you don't need to rank everything. People, when they go to see a movie on Netflix or they look at IMDb, they're probably not interested in movies with ratings of 3 or below. They want higher rated movies. So usually people just want to know the best recommendations. With content-based recommendations, you need to build a list of items. You need to have some method of creating profiles for your different items. So here I just arbitrarily assigned singing and action. One could do this by hand. One can use text mining with a synopsis of movie information, or with news stories, one can use things like term frequency, inverse document frequency, some algorithms in text mining to come up and create labeled and unlabeled data and be able to, with surprising but not 100% accuracy, say this is a liberal story, this is a conservative story, or this is a story about stocks and this is a story about sports, for example, would be an easy discernment. So that's really a 1,000-foot view of recommender systems. Here are 3 books that I would recommend. Mining of Massive Data Sets, which is freely downloadable at mmds.org. Also, you could buy the book. It's an excellent book. The 3 authors are Stanford professors who have a Coursera course by the same title, which is freely available. Programming Collective Intelligence and Algorithms of the Intelligent Web. None of these books are just on recommender systems. Chapter 9, Chapter 3, Chapter 5 in the 3 books cover recommender systems. Mining of Massive Data Sets is really about the theory and the math. Programming Collective Intelligence and Algorithms of the Intelligent Web focus on Python code with some theory and some math, and they're all excellent starting points. Another way people do targeting, and this is often used in conjunction with evaluating, comparing recommender systems, is A/B testing, which really could be thought of as a test with 2 different test cases. One could do multivariate testing as well. So an early example of A/B testing on the web, or a good example, was when money was being raised for the victims of the earthquake in Haiti in 2010. They had 2 versions of the web page, one with a submit button and one with a support Haiti button. And they found that in their A/B testing that the response rate as defined by people donating money was much higher with support Haiti. And the difference was attributed to increase the total amount of funds raised by $1 million just by changing a button. So it can be very significant. Now imagine that you're doing an A/B test for a new cancer drug, and the test is going to take, say, 3 months, and after 2 months you see that the control group or the test group is doing much better than the other group. Then there's an ethical challenge there whether to continue the test or not, because lives can be lost if you don't offer the better drug to both groups. So sometimes in testing, there are real ethical issues. There are also issues where you're designing something not only to provide the best opportunity for the customer, but you also have business goals, like you want to sell more product or sell products where you have more revenue from it. You have new products that you don't really know how they'll be rated yet. So you end up having to develop algorithms that are a little more complicated with what's called an explore versus exploit algorithm. And so it requires the person doing the analytics to work carefully with the business users or the organization's users to make sure that the different goals are being met and are being balanced. Maria Blecker tomorrow is going to talk more about marketing of these things. So I encourage you to take a look at her work as well. And we'll post a link to her information after this. So the implications of data-driven targeting, I want to drill down on the news feeds we looked at earlier. The example given as being the Wall Street Journal feed, but one could say, what happens if someone just watches Fox News or just listens to MSNBC? So back to the blue feed, red feed site, the way that the Wall Street Journal did it was, and they documented on the site, it was based on a Facebook paper that was published openly. There were just over 10 million Facebook users that were in the study. And in your Facebook profile, you can identify yourself as very liberal, neutral, conservative, or very conservative. And they took just the very liberal, people who self-identified as very liberal, and the people who self-identified as very conservative, and they looked to see what links were being shared, what news links were being shared more than 50% of the time only by people who were very liberal. And there were some other constraints, like there had to be at least 100 shares and that there had to be at least 100,000 followers of the site. So very small sites were excluded. Interestingly, Fox News was also excluded because it's not just very conservative. Conservative, neutral, and some liberal people watch Fox News. CNN similarly was excluded. The sites like MSNBC and National Review are included in the very liberal and very conservative feeds. So going back to the site, what the Wall Street Journal has done is reverse engineered the proprietary, not published feed of Fox News and come up with this very liberal or very conservative view of things. Now, this actually reflects how much of us get our information, and many of us just live in places where people have very like tastes to ourselves. So there's sort of a bubble of where we live and a bubble of where we get our news. There was a study done that on some hot button issue, perhaps abortion or gun control, I don't recall the issue, but it was designed to be a neutral 12-page study with some points that were more liberal and some points that were more conservative. And they asked people to read it after taking some questions to identify whether they were liberal or conservative on the issue. And what they discovered was that the more liberal people, after reading the same article, became even more liberal, and the more conservative people, after reading the same article, became even more conservative. And this is something called confirmation bias that two Israeli scientists came up with or described the phenomena. And it's kind of scary because what it means is that as people read the news, they tend to become increasingly partisan. And this has been documented with surveys that really since the turn of the century, the American public has become much more partisan, and the last 2 years, the acceleration has really increased. And social media and news recommenders are certainly a big part of this. Sites like Facebook are becoming a primary source of news for almost half of the people in the U.S., which means that a lot of people are getting their news from the Facebook recommender, which is designed to give you news that you like, largely, or seems to be. So in his new book, What's the Future and Why It's Up to Us, Tim O'Reilly of O'Reilly Publishing and Safari Online said, the systematic and increasingly algorithmic selection of news to fit and amplify people's preconceived views is causing whole sectors of the population to be led by vastly divergent maps. And this, to me, is a civil war of sorts, and I think it is very disheartening. And I think that news recommender systems are one component of this. It's not easy to fix. Here's a recent book that a lot of people have read. It's the second most read item on Amazon right now. And this is just an example of if you are writing in a hyper-partisan style, or you're a late-night liberal comedian, or you're Fox and Friends, your viewership goes up if you take a more extreme view. People in the center really are struggling to get eyeballs. So there are real benefits to individuals to be more hyper-partisan. If you are a politician and you are more to the left or more to the right, it's generally easier to get donor money, it's easier to get through the primaries, etc. It's a lot of challenges. So what can be done about it? I believe that people who are trained in doing advanced analytics, who often go on and do work at places like Facebook, building recommender engines, or Amazon or Spotify, are like nuclear engineers. We have the ability to profoundly influence our environments with potentially good or potentially destructive results. And I think because of this, it's important to encourage teaching of ethics in our programs. Weapons of Math Destruction by Kathy O'Neill, who's a PhD in math, who is a professor at Columbia University in New York, has suggested that data scientists should pledge a Hippocratic oath of sorts. Ms. O'Neill also feels that it's really important not to have opaque algorithms, that if you document the methodology behind your algorithms, they're less likely to be misused. An example of a document methodology is the FICO algorithms that give ratings for credit reports. You can see exactly how your score is constructed. So that's an example of methodology that's been published. She further has gone on to say that it will become necessary to regulate algorithmic use, and that may be the case. Regulation has its challenges, but it may be necessary. The last thing that I would suggest is educating people, training people to be more discerning about news, to ask who benefits when they're reading something. And going back to those two Israeli scientists, Daniel Kahneman and Amos Tversky, who I think they're actually trained as psychologists, and Kahneman, after Tversky passed away, won a Nobel Prize in economics. But they are, to me, the grandparents of the whole field of decision science, which data analytics and data science is built on top of. So I think I would really encourage people to read their work and think about how to train other people to be more discerning with information. That concludes what I wanted to talk about today. I'd love to take any questions or comments from people, and also to plug Maria Blecker's Marketing the Age of Personalization webinar tomorrow at noon. Our work is very interdisciplinary. So if you have a strong background in marketing or sports or entertainment or finance or risk management or energy management, combining that with analytics can be a very powerful way to be able to do high impact work. Are there any questions, comments, thoughts that people would like to share with us?
Hi, Andy. This is Kelly checking in. We have a couple of questions. The first one is, to what extent are online reviews reliable or valid, since not every customer leaves a review?
Yeah, good question. I'm not sure there's a great answer for that. Systems are gamed as well. I think that's even more concerning than statistical significance. So if there's only one or two reviews, that's going to be less important than if there's 10 or 100. And just like with Twitter followers, there are people who look to tweak the system on Yelp reviews and the like. One of the things that Amazon has done to try and beef up the quality of their reviews is indicate whether someone is a verified purchaser. Certainly looking for more reviews is a good idea. I think that Yelp in particular has tried to identify this. They've had a series of Kaggle challenges. If you go to kaggle.com and search on Yelp, they've tried to use methods to help identify quality of reviews, for example. But it is a challenge. Systems are gamed. I still think that reviews can be a great source of insight. Another example of reviews being challenging, if you look at IMDb, about 80% of the people who leave reviews on IMDb are men instead of women. When the new Ghostbusters movie came out, I'm going to make up the numbers because I don't remember exactly, but I think women gave it an average rating of about an 8, and men gave it an average rating of about a 5. you can actually go to the site and look on advanced options, and they have it broken down by gender and by age group. But if you look, then the average rating is a 6, which is a pretty mediocre movie overall. But if, let's say that you're a woman wanting to see Ghostbusters, you might really love the movie. And again, I'm being very general and a little bit stereotypical here, believing that women may have similar tastes and men may have similar tastes. But by breaking things down into subcategories, you also get different insights about things. So the aggregated numbers can also be misleading. I think looking for more reviews is a good sign in a lot of ways. Sometimes when you're looking at Amazon, for example, if it's an advanced book on analytics, like Introduction to Statistical Learning, someone who has no background might hate the book. Someone with a PhD in math might also hate the book because it's not as mathematical as, say, Elements of Statistical Learning. But so you have to kind of get a sense for what the reviewers are thinking as well. Great question.
Great, thank you. Another one is, can you talk a little bit more, or pontificate, I guess, maybe, about how we can use data analytics to solve hyperpartisanism?
I think making people aware of it is a really good way to go. I think the Wall Street Journal's red feed, blue feed is a really good example. It's challenging because the money is being made by being more hyperpartisan instead of less hyperpartisan. I think the Wall Street Journal is showing some incredible integrity of their journalism by publishing this site. I'm not sure in a systematic way how to go about doing things. In my program, I'm going to make sure that there's some data ethics taught to the data analyst in the program. I think having local initiatives where you teach people data citizenship can be very positive, but I don't know of a really effective systematic way to do things. Maybe Kathy O'Neill's right that ultimately there needs to be some regulation about documenting how algorithms are done. There is certainly a lot of interest right now on fake news and going on in Congress and how that's going to play out. Maybe more government involvement is the answer. I'm not always sure that's the right answer. So I don't have a single good answer there. Sorry. Oh, one other thing I'd add is I think being empathetic really helps. So people who are very liberal, I think if they read a book like Hillbilly Elegy or White Working Class, which are really more anthropological studies, not political work, but they describe the suffering of some of the people who voted for Mr. Trump, would give people insight into that side of the fence. Similarly, I have friends and colleagues who are very conservative who may have done mission work or volunteer work in third world countries where that may soften hardened views on immigration, for example. So I think if we are living among people with diverse opinions that we see as friends and not enemies, that helps a lot. But that's a little bit, it's not a very quantitative answer.
No, that's fine. Great. And then we have another question that I'm going to put into the chat box in case I'm pronouncing the tools incorrectly. But so it's, do you have any data visualization tool that you recommend learning, like D3.js or Bokeh?
Yeah, great question. In our program, we're going to use Tableau, which has the advantage that it's very inexpensive academically. And the corporate licenses are very expensive. The tools like ClickView are also very popular. One of our faculty members from Chase uses ClickView internally. D3JS is a wonderful tool. Bokeh, Bokeh. In the R environment, I really like Shiny as a tool for doing data visualization, and you can build some nice products around it. I think of the listed tools, D3JS is the most flexible, and on the other end, tools like Tableau and ClickView are more graphical user-driven tools. But I personally really like the tools like D3 and Bokeh. I also think that if you're going to do infographics, for example, those can be really useful tools. Speaking of graphics, I think it's worth just mentioning that there are a lot of different, to me, are three different purposes of graphics. You can use graphics to explore your data, which is a necessary part of analysis. You can use graphics to explain your data, which is when you're talking to other people about your findings and recommendations. And you can also use graphics to persuade people. So exploration, explanation, and persuasion are three different audiences, and it's probable that you may use different tools for the different audiences. Again, a great question, and that's at best a partial answer.
Fantastic. So two more questions. First being, what type of student are you looking for in the data analytics master's program?
Well, on our website, we have a list of requirements, starting with a bachelor's degree, because it is a master's program. I think that you will do well in the program if you love working with data, if you really enjoy using data to solve problems, to make organizations better, or to do social good, or sometimes both at the same time. Just like with computer programming or ballet dancing, it's a very tough field to be in if you don't enjoy working with data. And so I think the secret ingredient to being successful in the program is really wanting to work with data to solve challenging problems.
Fantastic. And the last question is, how do you see the future of data analytics evolving?
That's something I'd love to have a lot of people weighing in on. There's certainly a big trend toward commodification of what we did yesterday. So 15 years ago, I had a business intelligence consultancy in New York, and we were doing state-of-the-art work then. And I was doing some financial engineering work that is now considered table stakes in the field. So as Moore's law kicks in and more great software, most of it open source, is built, and we're building on top of libraries and things like the Microsoft Cognitive Toolkit, the Google Computing Platform, all the amazing libraries being done in Python and R, tools like Spark and even Hadoop. We can do more and more with less and less. I think that what this means is that in 5 years, the kind of work that might today require a data scientist with a PhD, and 5 years ago may have required a PhD in experimental physics, will be something that someone with advanced analysis can do. An example of this would be using Google tools and Google's spreadsheet. You can now call functions in the Google Cloud environment to do image recognition and text transcription that would have required hundreds of lines of code and taken long time to run. Similarly with neural networks, the ability to take a neural network that someone else has built and trained, perhaps running for thousands or tens of thousands of hours, and plugging in your own data, even different data to it, and getting very acceptable results. So I think basically every year we can do more and more things that 5 years ago were really cool. 5 years from now will be self-serve. So another challenge or opportunity in our field, in my opinion, is that the things that you learn in school will be less important in 5 years or 10 years. I believe, I hope that we've designed into our program, and I believe and hope that most other programs will attempt to do the same thing. Basic scientific method, patterns of analysis that occur across platforms change much more slowly than the tools. So it's a constantly evolving field, constantly evolving tools, and it's an exciting place to be if you love learning new things and love working with data. But it's challenging. It requires continuous effort to keep up.
Great. Thank you so much, Andy. And it looks like that's all the time we have today. So I just want to thank everybody for joining. Andy, feel free to, if you have any last send-offs, you can let us know. But I just wanted to let everyone know we'll email you this recording as soon as it's available. And we hope that you can join us tomorrow for Maria's webinar or for future webinars as they come up.